Hey guys, hello everyone. Welcome back to 360DigiTMG's domain analytics program. How are you all? Yeah, I hope everybody is fine. Okay, in the last session that we have discussed, in the very first day, we have discussed about the machine learning applications when it comes to healthcare. Where exactly we can do improvements using the machine learning that we have discussed, like classifications, segmentation, or we can say clustering. How can we implement the machine learning when it comes to automation? There are some operation we should do very taking care of everything. In that case, if it is human, there might be some chances of doing the human error. So if you deploy the machine learning, in that case, we can improve the quality of that particular operation. Something like that, we have seen different application and how can we improve the healthcare analytics using the machine learning. And the very second day, we have discussed what are the different algorithms we'll be having when it comes to machine learning. In that, we have discussed supervised, unsupervised, we have discussed the supervised models and unsupervised models, and we have discussed evaluation metrics. We have discussed evaluation metrics for classification as well as regression. And we have also discussed what are the overfitting. What is the overfitting? And what is underfitting? And how can you avoid this overfitting and underfitting? We'll be having different methods, techniques, so that we can avoid the overfitting. That also we have discussed. In today's class, we'll be discussing about pre-processing techniques. So whenever you receive data from different organization or from your client, in that case, it is not perfect one. So there might be some human errors. There might be some data intentionally missed, and there might be some data people don't really want to reveal that. So in that case, there are so many cases. Due to that, we will be having some missing values in our data. So data won't be perfect. In that case, what we have to do, we can't really feed the data as it is to the model. So we have to do some pre-processing. Before feeding the data to the model, we have to do some pre-processing. And here we'll be discussing the EDA as well. What is EDA? Whenever you receive data, you are supposed to go through data. What is it? What is the data is about? You have to go through feature description. You have to try to understand the data, and we have to visualize, and we have to bring out some inferences from the data. That is why it is called as an exploratory data analysis. We have to explore the whole data, and you have to come up with some inferences. How are you going to do that? We'll see. So EDA means exploratory data analysis. Exploratory data analysis. Data pre-processing in healthcare analytics. We'll be seeing how we're going to do the data pre-processing when it comes to healthcare analytics. Not in the case of healthcare analytics, in every analytics will be every domain, you will be doing the same pattern will be following, the same hierarchy will be following. But in some cases, let's say missing values. If you have some missing values in other domain, in that case, you can do some imputation using mean or median or mode. But when it comes to healthcare, you won't be able to do imputations. In that case, you have to look into that. You see, when you are working on some healthcare and you have found some missing values in your data. In that case, you won't be able to impute with random values, right? Each entries of different people, so it is very unique. In that case, doing the random imputation, I don't think that makes sense. So you should be aware of that, where you have to apply the imputation, where you shouldn't apply the imputation. Especially when you are working on healthcare analytics, you should be aware of that. So in exploratory data analysis, what we have, we'll see. Exploratory data analysis refers to the critical process of performing initial investigation on the data so as to discover the pattern. Whenever you receive the data, it is kind of doing the investigation on data so that you can find out some patterns. Each entry that you have in the data, it is a kind of pattern. Those pattern only we are training to the machine learning. Whenever we have a data that is in the form of entries, those are all different patterns. You have, like, let's say you have 100,000 entries. Those are 100,000 patterns, different patterns. What happens when you have these inputs? What will be the output? What happens when you have other inputs, different inputs? In that case, what will be the prediction? Those are all different patterns. Those patterns only we will be training on machine learning. Machine learning learns those patterns and it come up with a new logic. Machine learning comes up with new logic. Then whenever we are supplying the new data to that particular machine, whatever the learning that he did or that the machine learning did using the data, that we have given, the pattern, whatever the pattern it is learned, it has come up with logic. Whenever you are supplying the new data, it will come up with the one prediction based on the pattern that he learned or it learned. So it is all about the data. So each and every entry has different patterns. So how do we start EDA? That is exploratory data analysis. Starts by asking some basic questions of data set to make initial assessment of the data structure. So right after receiving the data, just do a quick search on those particular features. Whatever the features we have, we might not have, even though, see, data scientist works on various domains. In that case, it doesn't necessarily need to know all the meanings of each and every term. In that case, you can do some quick search and understand what exactly the feature is about, or you can simply contact whichever the client you have. You can contact subject matter expert and try to understand what are the exact meaning of those particular columns. And then based on those data, try to ask this question: is there any existing unique records ID we have in that particular data set that has provided by the client? Our fields are populated with numbers, dates, and alphanumerical columns. What are these means? See, whenever we have received the data, in that case, we'll be having different data types. Some it can be textual, some it can be numerics, some it can be dates. So we have different data types. We have to ask which data type that belong to, that particular feature belong to. How many values exist for categorical fits? How many categorical values or categorical feature we have in our data set? That you have to go through. Based on that only, we will be doing all the pre-processing. When you have a numerical data, and if you want to do some missing data in your numerical, so in that case, what you can do? Based on appropriate imputation technique, we can apply. appropriate imputation techniques. What are the imputation techniques? We will discuss in the next slide, but you have to have an understanding about the data. Whatever the data that you have received, you should have an understanding about the data. That is why you have to go through the whole data frame once you have received and do some quick research about the particular column, or you can simply contact your SME, whichever the client the data has been provided. You can contact that SME. So once that is done, once it is done, then you have to do some visualization. So then only you will be able to understand how data is spreaded, how is the variation of data. So in that we have graphical analysis. For that we'll be using the Matplotlib. It is one of the library that we will be doing the visualization. And we have also have Seaborn for the visualization. So in visualization, we have univariate analysis, bivariate analysis, and multivariate analysis. What are these? If you want to plot the single feature, whatever the features you have that are x1, x2, x3, these are the features. And this is the label, or you can say it is an outcome or output. You want to just visualize the one feature. In that case, you can go for univariate analysis. In univariate analysis, we will be having bar plot, histogram, and box plot. It will simply show you how your data, whatever the feature or column you have, how it is spreaded, how is the variance, whether it is symmetric or non-symmetric. All those things you will come to know using the bar plot or histogram. Box plot, even using the box plot, you can find out the symmetry of your particular feature. What are the symmetry and all those things we'll discuss in a minute. Bivariate analysis, when you want to compare two features, whatever the features we have, when you want to compare two features or you want to find a relationship between the two features, in that case, we will be going for scatter plot. In that case, in x-axis, we will be taking one feature and y-axis, you will be taking one more features. And then you can do plot and compare both the features, whether they are related or not. What is the relation between that? That you can find out using the scatter plot. And we have multivariate analysis. Name itself saying what is a multivariate. When you have more than two. When you have more than two features in your plot, in that case, it is a multivariate analysis. We'll be having a pair plot and heat map in order to find out the relation between or dependency between the independent variables and independent variables to dependent variables. Then we will be going for heat map. In that heat map, all the features, whatever the features we'll be having in our data frame, and the label. So what is the difference between each feature and the label? There is a dependencies. It will simply show the dependencies. Something like in between 0 to 1. If you have 1, it will be the highest dependency, the maximum dependency it has. When you have 0, it is the minimal dependency. Means it doesn't have any dependency on particular feature. So just to compare each and every feature and how they are dependent on each other, and also how they are dependent on the output variable, that is called label. We'll be doing that using the heat map. Yeah. When it comes to pre-processing, we have different techniques in order to clean the data. we have different techniques. Those are typecasting. We'll discuss each and every technique in detail. Typecasting, what is typecasting? Handling duplicates, you might have understand just by listening that name, duplicates. Outlier analysis and treatment, zero or near zero variance, discretization, missing values, dummy variable creation, transformation, standardization, string manipulation. These are all techniques in order to clean the data. Okay. When it comes to typecasting, what is typecasting? When it comes to typecasting, whenever, let's say most of the time, whenever you are initializing variable in Python, variable initialization, Python itself takes, you don't need to mention it is an integer, it is an object, something like that. You don't need to mention. Python itself takes based on the data type. In that case, it might be sometimes age or weight. You can represent your weight in 28 kg, something like that, or you can represent something like 28.0. So if you want to use the weight column in float, but whenever you the data, whatever the data it is given, it is simply 28. In that case, what Python do? It will take as an integer. But you don't want to take it in integer, you want to convert into float. In that case, you can use the typecasting. Typecasting means simply converting one data type to another. Converting one data type to another data type. It is called typecasting. When it comes to handling duplicates, see, whenever you have a data frame, let's assume it is your data frame. Entries, entry 1, entry 2, entry 3. When these entries are exactly same, any of these entries, any two or multiple, any of these entries are exactly same, in that case, it is called as a duplicate. It is copy exactly. If it is entry 1, let's say it is 5, it is 7, 8, 9, and yes. Here also same, exactly 7, 8, 9, and yes. The same information is present in 2 entries. In that case, what it is called? It is a duplicate. So same information given in 2 entries. In that case, there is no use, right? When we are taking the same information again and again, in that case, same information is provided in 2 entries. So you don't need duplicate. For duplication, we don't have any imputation, something like that. Simply remove it. Whenever you have found duplicates, simply remove from the data frame. Handling duplicates, that is only way. Whenever you have found duplicates in your data frame, simply remove it. Outlier analysis and treatment. So what is outlier? First, you have to understand what is outlier. Extreme values. Extreme values is extreme high values or extreme low values. Both comes under outlier. So how do you decide whether it is extreme value or not? We will be doing the box plot. In that, by just doing the box plot, you might be getting what are the outliers present in your data frame. Or you can simply observe your data. Let's say you have one grocery store. Let's say you have one grocery store. Every day you are getting sales of like 100 rupees. Day 1 you got 100. Day 2 you got like 130. Day 3 you got 150. Day 4 you got 130 again. So this is your regular transaction, and suddenly on day 5th you got like 1000 rupees. So is it is gonna last for a long time, or it is just for one day? That you have to observe. In order to deal with outliers, we will be having like 3 techniques: rectify, retain, or remove. And remove. What is rectify, retain, and remove? First, we'll see whatever the observation we made. Is it genuine entry? Is it going to last for a long time, or simply there for just one day? If it is a genuine entry, how do you know whether it is genuine entry or not? You will check other entries as well. In that case, also, if you are getting near to 1000, in that case, you can consider it as a genuine entry. But if it is not the case, again it is started having the sales of 130. In that case, whenever you are taking average, it will disturb the data. Normally, whenever taking the average, it should be like in between 130 to 120 to 130. But whenever there is a extreme values in your data, whenever you have extreme values, then the average might get affected. Average will be affected, not might, it will be affected. So it is not a good measure. In that case, what we'll do? We will remove the outliers. Whatever the outliers we'll be having, we'll simply remove it, and then we will do the model building. So whenever you have extreme values, so the more perspective, the average value will be getting affected. Suddenly you have 1000. In that case, if you want to find out what is the average sales you are getting in week, normally it is just 130, but because of this extreme value, it might get affected and you might get 200 plus. So it is not a good thing, right? Is it representing the exact real value? No. In that case, we will be eliminating the outliers that could be extreme low or extreme high. For that, we have different box plot that follows some formula. So in this 1 hour session, it is not possible to go through all those things. But just remember, whenever you have extreme values, that could be high, that could be low, you can simply remove it. That is called treatment. We have different techniques to remove. That is, one is trimming, and one is winsorization. So these are the 2 outliers treatment techniques. In the trimming, what we will do? We will simply delete the outliers from data set. From data set, we will simply removing the outliers. I mean, in that case, you will be losing the data as well. And when it comes to winsorization, we will be replacing those extreme values, with upper limit and lower limit. What are upper limit and what are lower limit? See. It is a box plot. Whenever you are finding the outliers, you will be using box plot. It is a minimum value. It is a quartile 1, it is quartile 2, and it is a quartile 3. And it is a maximum value. The upper limit will be calculated as upper limit is equal to Q3 plus 1.4 into Q3 minus Q1. When it comes to lower, Q1 minus 1.5 into Q3 minus Q1. Q3 minus Q1 Q3 minus Q1. It is also called as IQR, interquartile range. Q3 minus Q1 is also called as an interquartile range. How much information is present in just quartile 1 range, quartile? It is also 25%, 50 percentile, and it is 70%. The information is present in 25 percentile range, that is Q1. The information is present in 50 percentile range, it is called Q2, and 75 percentile range, it is Q3. In order to find out upper value or upper limit, we will be using the Q3 plus 1 by 1.5 into Q3 minus Q1, and lower Q1 minus 1.5 into Q3 minus Q1. These are the upper and lower limit values. In visualization, we will be replacing with, if you have extreme value near to upper limit, in that case you are simply replacing with upper limit. When you have an extreme low value near to lower limit, in that case we are simply removing with or replacing, not removing when it comes to visualization, replacing with lower limit value. That is the outlier limit. And zero variance and non-zero variance. So it is all about the information. Let's say you have column X and X2. All are male. All are male. All the information is male. Or X2, we have all are just single number. Single number. In that case, there is no variance. The variance in the sense, it is the information. You won't be able to get any information from the data. If there is no variance, we simply ignore that columns or features. When there is no information or there is no variance in the feature, in that case, we will simply ignore those features because we are not able to collect any information from that particular feature. So it will simply ignore it. When it comes to discretization, whenever you want to group, let's say you have a salaries of different people. In your organization, you are working on an organization, you want to group them into high salary people and low salary people. You want to group them into high salary people and low salary people. You are simply converting the continuous values into discrete. So whenever, in that case, you can simply say whoever having more than 50,000 salary, that comes under high salary. Whoever having less than 50,000 salary comes under low salary. So you are converting the continuous. What are continuous? 50,000. These are all salaries are in continuous values only. You are simply converting the continuous into discrete. It is called discretization, or you can say binning as well. And missing values. In your data set, some values might be missing randomly, and some people intentionally may not be providing the information. In that case, we will be doing different imputation techniques based on the feature or based on the data frame, whichever the project you are working on. If it is making sense, to replace with mean, median, or mode. So mainly we'll be having these imputation techniques. When you have age column or numeric column, you can simply go for mean imputation. If you have outliers in the data, you can go for median imputation. If you have a categorical data, when you have a categorical data in your data frame, you can go with mode imputation. So we have different missing values, like missing completely at random and all those things. But mainly just remember, how can you deal with the missing values? You can deal with missing values with imputation. Other techniques also we have, but mainly we'll be having mean, mode, or median imputation, depending on the data type. If you have a numerical data, you can simply go with mean or median. If you have outliers in your data, you can go with median, because outliers Because of outlier, mean will be affected. So we have to go for median. Yeah. Dummy variable creation. Whenever you are having categorical data. What is categorical data? Textual. Say textual. Columns, if columns are categorical. In that case, you have to convert into numeric. Whenever you are having categorical data, you have to convert into numeric. Why? Because model won't understand the categorical. Model won't understand the categorical data. So that we have to convert those categorical values into numerics. Then only it will be able to understand. So for that, we have different techniques. Dummy variables, dummy variable creation, one-hot encoding, label encoding. Like that, we have different encoding techniques. What happens in dummy variable creation and one-hot encoding and label encoding? When will we be using all those things? In dummy variable creation, whatever the columns, whatever the let's say it is a column in the country, and in that you have entries like India, USA, and France, anything. Whenever you are using the dummy variable, then a new 3 columns will be created. It is a country underscore India, country underscore USA, country underscore France. These columns will be created when it comes to dummy variable, and wherever the India is present, it will be one-hot. It is 1, rest 0, 0. When it comes to USA, wherever the USA is present, it will become 1 and rest will be 0. And France, whenever the France is present, it will be 1 and rest will be 0. This is what happens when we do the dummy variable creation. And when it comes to one-hot encoding, it will give the exact results, but instead of column names, dummy column names, it will simply give 0, 1, 2. That is the only difference between dummy variable and one-hot encoding. When it comes to label encoding, it will simply in just one column, one feature. Based on the alphabetical order, it will simply give India first. It will be 1, and India is 2 and 3. The country, column name remains same, but it will simply give the numbers to that particular unique value. These are called unique values. This is a column that is feature. In that, we will be having unique values. So it will based on the alphabetic order. France comes first, so it will just give 1, India 2, and then USA. This is how encoding works. Whenever you have, these are the categorical inputs we'll be having. And if you want to convert the categorical inputs to numerics, it will be displayed something like that. When it comes to label encoding, it is for label encoding. Transformation. Whenever see, we will be using the histograms to check whether whatever the data present, whatever the feature you have in your data frame, if it is normally distributed or not, we will be checking using the histogram. How do you decide whether you have feature which is normally distributed or not? When the data frame or the data frame in your data frame, whatever the feature you are taking, it is a univariate analysis. Univariate analysis. If your data is in bell-shaped curve, let's say it is a age column. If the age column is in bell-shaped curve, in that case, it is taken as the symmetric or normal data, you can say. Normal data. Whenever your data spreaded in a bell-shaped curve, in that case, it is called as a normal data. If it is not normal data, when you have a non-normal data, how can we decide if it is right skewed or if it is left skewed? Other than the normal, other than the bell-shaped curve, if you have any other form, in that case, it is called as a non-normal data. In order to convert non-normal data to normal data, you have to do transformations. When there is a tail on the right side, it is also called as positive skewness. We'll discuss that in the next slide. But it is a non-normal data. When you want to convert non-normal data to normal, that is called as a transformation. In that case, what happens? Whole non-normal data will be converting into this non-normal data converting into normal. For that, we have something like log transformation or 1 by x square root x. We have different transformation. We simply apply on the feature and we'll try to convert this non-normal data into normal data. This is transformation. Why we are converting the non-normal data to normal data? Because whenever we are working on the statistics, we are assuming that whatever the data present in our data frame, is normal. By default, we are saying these are normal. Then only we can able to apply all the statistics. Then only we will be able to apply all the statistics. Then only, we can find out some inferences. That is why whenever you have a non-normal data, we are converting into normal. That is called transformation. Standardization. We have standardization and normalizations also we have. So what is normalization and standardization? Let's say we have x1, x2, x3, x4. These are the features. In your data frame. And you have output saying y. This is your data frame. When in data frame x1, you have a column something like 0.5, 0.6, 0.8. Here you have 20, 30, 40, 10,000. 15,000, 6,000, 60,000, and here are 1, 2, 5, 6. You can clearly observe there is so much difference in the data. So much difference. X1, it is just present in points, and it is just 2. And X3, it is in thousands, and it is just 1. If there is so much variation in independent variables only, then whenever you want to do prediction, the influence of X3 is more compared to other columns. Influence of X2 is more compared to X1 column, and influence of X3 is more compared to any other column. So in order to avoid this influence, in order to avoid this bias, in order to avoid this biased prediction, what we are doing? We are doing the normalization and standardization. Any one of those. What is the reason? What is the main agenda of doing normalization and standardization? We are bringing different scales we have, right? In this feature, we are bringing all them into single scale. All the inputs, whatever the inputs we have, we are bringing all those inputs into single scale. That is called normalization or standardization. What happens in normalization? All the values, whatever the features, different features, 10K we have, 0.1 we have, 20 we have. All this comes under 0, in between 0 and 1. All these entries, all these feature entries, we will be converting into in between 0 and 1. Whatever the values we will be having in the new data frame after normalization, all those values are present in between 0 and 1. That is called normalization. When it comes to standardization, the values range from -infinity to +infinity, but mean equal to 0 or standard deviation is equal to 1 when it comes to standardization. For normalization, simply all those values are converted into in between 0 to 1. That is a standardization. String manipulation. It is, we'll see when we do the text pre-processing. So whatever the things that we have did till now, it is for numerical data. So when you have a structured data, you can say, whenever you have a data in the tabular form, whenever you have a data in tabular form, and if it is structured data and you have so many continuous numerical values, in that case you can go with pre-processing, whatever the pre-processing that we have discussed, we can go with that. But when you have unstructured data, what is unstructured data? What is structured data? When you have structured data, it is in tabular form. Data is in tabular form. This is X1, here X2, X3, X4, and it is Y. Whenever you have a label, you should go for supervised learning that we have discussed in the last class. When you don't have a label, you will be going for unsupervised learning. These are different models. So it is in tabular form. Then it is called as a structured data. When you don't have data available in tabular form, in that case, what it is called? Unstructured data. When data is not available in tabular format, in that case, it is called as a unstructured data. In that case, what we have to do? Whenever you want to work on unstructured data, you have to process. The pre-processing for structured data and unstructured data is completely different. Especially when it comes to text pre-processing. Text pre-processing, it is completely different. What are the things that we will be doing when it comes to text pre-processing? We'll see. So whenever you do collect this text data, What are the possible anomalies you can find? What are the possible anomalies you can find in your text? If you are, let's say, you are finding the reviews. In that case, what will happen? People might do some spelling mistakes. Some might use short forms. There could be so many links, HTML links. There might be special characters, so many special characters. Whenever you are doing the pre-processing, you have to go through all of this and you have to remove it. And you have to clean the data. You have to clean data. In the sense, you have to remove all those anomalies from your data. How do we gonna do that? Let's say you have different libraries when it comes to NLTK. NLTK libraries like autocorrect. What it will do? So whenever you are finding the spelling mistakes in our data, it will look into it and it will automatically correct whatever the spelling mistake we will be having. It will simply remove it and it will replace with whatever the dictionary word will replace with the dictionary word. That is an autocorrect. And we are, let's say, and what else we have? Spelling mistakes. Yeah. And you want to do POS tagging, parts of speech tagging. We want to find out what whatever the sentence we have, which parts of speech that particular word belong to. In that case, you can do POS tagging, parts of speech tagging. And sometimes, if you want to do sentiment analysis, you have to have the only words that represent some sentiment. In that case, we don't need to have all the data, whatever the present data present in that corpus. What is corpus? Whenever you have a textual data, or if you are collecting the different reviews, collection of all the reviews, or collection of all the inputs, it is called as a corpus. It is a collection of all data. Simply, it is a collection of all data. Yeah. We have POS tagging. We have auto correction. We have NER, name entity recognition. Whenever you are doing the sentiment analysis, you don't be needing other than the words which represents sentiment or kind of some emotions. Let's say you want to do sentiment analysis on reviews. It could be some product review or movie review. Whenever you find all the reviews, you will store in one data frame. It is called as a corpus. Then what you do? You will simply apply the autocorrect. If there is any spelling mistake, in that case, it will be replaced with the actual word. And then we will be doing the tokenization. What is tokenization? Whatever the sentence we have, and wherever there is a space, it will split into a single word. These are called tokens. Whole sentence will be splitted into different tokens or different words. Then only you will be able to understand. Then only you will be able to go through each and every term and to bring out the sentiment present in your data frame. So in that case, You don't need to have all those conjunctions, something like and, of, all those. Those doesn't represent any emotion or any sentiment. In that case, what we'll be doing, we'll be using the stop words. In NLTK library, we'll be having some default stop words that doesn't represent anything, that doesn't represent any emotion or any kind of feeling. In that case, you can simply use the stop words and you can remove the words which doesn't represent any emotion, and then you can bring out the words which are representing the emotion or that related to some particular product or related to particular movie. When it comes to normalization, what is normalization? So let's say in one sentence, repetition of that particular word is more. Term frequency it is called. Term frequency. How many times that particular word present in the sentence. So whenever you are doing the sentiment analysis, we'll be forming one word cloud. Whenever there is a word repetition is more, the word size keep increasing. Word sizes keep increasing. So if just one person is mentioning the same word name repeatedly, in that case, the size will be increasing when it comes to in word clouds. So it doesn't reflect actual public review. So if you are taking just one person's review, if he is mentioning the same word 100 times, so automatically the word will be increased, right? So in order to normalize, or in order to remove that, we will be going for TF-IDF. Term frequency and inward document frequency. Instead of taking the single review, we will be considering the whole document. How many times that particular word is present in the document. Based on that, we will be doing the we will be going for sentiment analysis and forming the word cloud. In that case, this issue will be resolved using the normalization. Noise removal means the same. Whatever the anomalies present in our data frame or corpus, will be calling when it comes to textual preprocessing or text preprocessing. Text preprocessing we will be calling as corpus. If you have any empty reviews, in that case we will be removing those with nothing. We'll be giving nothing in order to replace all those things. And if you have any auto correction, that also we can spelling mistakes that we can remove. And if you have anything short forms, good, nowadays people just simply use good. In that case, you can replace with the nearest word. You can look into it dictionary, and you can come up with. For that, we have something like lemmatization. Stemming. What stemming do? Whatever the extension we have, whatever the extension, like say playing, it will simply convert into stem word or root word. And sometimes stemming doesn't make sense. So to avoid that, we will be using lemmatization. It will look into the dictionary, whatever the stemming is done. Is it present in the dictionary or not? If it is present in the dictionary, it will simply replace with the whatever the word we have in dictionary with the same. If it is not present, we will be replacing. If it is present, we will keep as it is. That is about. Yeah, what we are doing, especially in our text preprocessing, what are the things that we are removing? We will be removing HTML tags. If you have any white spaces, extra white spaces, we will be removing that, because converting ASCII standard, we will be having some ASCII standards for words. We will be converting into that. Expand contractions, remove special characters. See, whichever not necessary. If you are going for sentiment analysis and you want to form word cloud, whichever the words present in that corpus, that only we will be taking. Other than that, we are simply ignoring it. So whenever we are working on textual data, we will be converting whole text into lowercase, because text mining or NLTK, it will take, it is case sensitive. Let's say usage or usage or USH. So these are all different. First you have used capital letter, then you will use small letter and capital letter, small letter and capital letter. These are all different words when it comes to NLTK library. To avoid that, we will be converting all into lowercase. So that the words won't be repeated. The words won't be repeated, and then we'll be converting all this categorical word into numeric. That we will be doing using the term frequency to avoid the whatever the situation that we have discussed in the previous slide. We'll be using the TF-IDF, and numbers won't be representing anything when it comes to sentiment analysis. So what we are doing, we are simply removing this numbers. And stopwords, those also doesn't reflect any sentiment. In that case, we'll be removing stopwords. We'll be having some default stopwords in an NLTK library. We can do that too, or you can additionally supply your custom stopwords. You can additionally supply the custom stopwords in order to remove the word, because those have no use. Those represent nothing. So you can simply remove using the stopwords. Lemmatization. See, whenever doing this stemming, like I've explained earlier, let's say playing, we'll simply convert into play. Cry. Simply convert into cry. Removing the prefixes and suffixes, it is called as a stemming. So in stemming, what happens sometimes whenever you're doing stemming, it doesn't make any sense. To avoid that, we will be using the lemmatization. Lemmatization, what does lemmatization do? It will look into the library dictionary. Whatever the word we are doing the stemming, is it present in our dictionary or not? If it is present, it will keep it as it is. It will keep as it is. But if it is not present in our dictionary, it doesn't making any sense. In that case, near whatever the dictionary, whatever the word that is present in a dictionary, it will replace with near word or dictionary word. It will simply replace with the dictionary word. That is the lemmatization. So it is, you can say, when it comes to stemming and lemmatization, it is a bit intelligence comes to doing the stemming. Compared to stemming, lemmatization is a bit intelligent, because it will look into dictionary, then only it will replace. Yeah, these are all different pre-processing techniques, guys, when it comes to pre-processing. These are the different pre-processing techniques when you have a structured data and when you have unstructured data. Those are a bit different. When you have a structured data, the pre-processing techniques are completely different. When you have a unstructured data, that is textual. In unstructured data, we'll be having videos, images, text. These are all comes under unstructured data. Then what we have to do? We have to convert them, we have to clean them, and then we have to convert into bag of words and TDM, or you can say DTM. Document term matrix. We'll be converting those unstructured data into structured data. Then we'll bring down into tabular form. Then we'll do the sentiment analysis or any other algorithm we will be applying on that. So this is all about the pre-processing techniques of different structured data and unstructured data. I hope you guys learned something. And if you want to if you want to learn more, you can simply follow our 360 DigiTMG channels. This is our LinkedIn, and here this is our Facebook. And in the next class, we'll be discussing about the clustering. In next class, we will be discussing about the clustering, how we're going to implement this clustering in healthcare analytics. And we'll be taking one use case scenario and we'll be discussing in the next class. I hope you guys learned something, and we'll see you in the next class, and have a nice day.